Previous lecture, we have talked about isomerism. Okay, we have two types of isomerism. We have constitutional isomerism and also stereoisomerism. Okay, so constitutional isomerism is the one that you have learned during your SPM time. Okay, so this constitutional isomerism can be divided into chain isomerism, positional isomerism, and functional group isomerism. Okay, all right, and the other type of isomerism is known as stereoisomerism. So for stereoisomerism, we have two types of stereoisomerism. We have geometrical isomerism and optical isomerism. Right? Okay. Okay. So for this constitutional isomerism, we have one checkpoint. Okay, that I have asked everybody to complete this checkpoint, and we will discuss the answer today. Okay, so for checkpoint number 4, you have to draw any 3 chain isomers of C7H16. Okay, this is with respect to chain isomers. It means you can play around with the chain. Okay, so make sure that as long as the carbon in the molecule need to be 7 carbon and 16 of hydrogen. Okay, all right, so you may play around with the carbon. Maybe you can have a branch. Okay, have one branch, have two branch. That will be the chain isomers. And then secondly, you have to draw any 2 positional isomers of C5H12O1. Okay, all right, so you have to identify the type of compound is this. Okay, the type of compound that we have here. So then from there you can play around with the as you can see, we have oxygen, and one oxygen there. So you have to identify the homologous series for this compound. Okay, is it alcohol or is it aldehyde? Okay, the one that has only one oxygen, is it alkoxy? Okay, so you have to identify, and then if you found out that the functional group is, for example, hydroxyl group ataupun homologous series is alcohol, that means you have hydroxy group in the molecule. Okay, so since it mentioned here positional, so you can place the OH, the functional group of OH, maybe at carbon number 1, carbon number 2, carbon number 3, and then maybe you can have a branch, and then we have OH there. Okay, so that will be 2 positional isomers, but you have to identify the functional group first because we have oxygen there. Okay, and then C, draw any 2 functional isomers of C5H10O. Again, you have to identify what are the possible functional group that may have this chemical formula. Okay, it can be ketone, it can also be aldehyde. Okay, so those are considered as functional group, carbonyl. Okay, it definitely will not be carboxyl group or carboxylic acid, because for carboxylic acid it need to be 2 oxygen, right? Or ester. Okay, so definitely it won't be ester or carboxylic acid. So it can be carbonyl. Okay, functional group carbonyl. So if it is carbonyl, that means it can be aldehyde or ketone. Okay, all right. So, but as you can see in this question, the question did not specify whether you have to prepare in terms of skeletal, condensed, or expanded. Okay, the question did not specify that. That means all can be accepted. Okay, you can have in terms of expanded, skeletal, or condensed, or even mixture of these 3. Okay. Okay, so what we have here, these are the answers. What we have are in the form of skeletal. Okay, you can always compare with the one that you have. Maybe you have it in expanded form. Doesn't matter. Okay, as long as it is actually the same molecule lah. Okay, it's the same molecule. So these are skeletal. Okay, so for C7H16, actually we can have more than 3 lah. But the question only asks for 3 chain isomers. So we can have all of this. These are all skeletal structural formula that are possible for C7H16. As C7H16, this is alkene without double bond. Okay, alkenes. And then we have B. Okay, like I said just now, you have to identify the functional group first. So once you know that it can be alcohol, homologous series is alcohol, or hydroxyl group as a functional group, you can simply play around ataupun place the OH maybe at carbon number 1, and this is carbon number 1. Okay, this is carbon number 1, number 2, number 3, number 4, number 5. Okay, all right, so that's why it's called pentan 1 all. So it can also be placed at carbon number 2 and also can be placed at carbon number 3. Okay, so this is not carbon number 4. Okay, guys, carbon number 4 with respect to this if we start from here. But if we start numbering from here, then it should be carbon number 1, number 2, number 3. Remember, for IUPAC naming system, we have to get the lowest number as possible for the functional group. Okay, that one we will cover later lah in the IUPAC naming system. Okay, this is for C. Okay, all right. So in terms of functional group, so we have first example. This is in terms of aldehyde. So actually we have H here. Okay, but since this is skeletal, fully skeletal, so H is not shown. But you should know that for aldehyde, we have a hydrogen attached to this carbon. If not, this carbon is not octet. Okay, you have to always make sure that the carbon should achieve octet. Okay, all right. So this is aldehyde and this is carbonyl also, but the homologous series is ketone, ONE ketone. Okay, so you can differentiate for aldehyde, the carbon is the terminal carbon. Okay, the terminal carbon, the MOS N. But for ketone, the carbonyl group here is in the middle ataupun in between 2 carbon. Must be between the 2 carbon. Then it is called ketone. Okay, same goes to this one. This is also ketone. Okay, this is also ketone. It is non-pentan 3 on. This is the carbonyl, right? The carbonyl group. So it is between these 2 carbon. Okay, all right. So this is another example. So this is cyclic form of molecule, but this will not be covered in our syllabus lah. So we have 1 oxygen in cyclic form. Okay, all right. Yeah, so that is all for constitutional isomerism. Okay, next we have stereoisomerism. So we have talked about geometrical isomerism, but we are yet to cover this optical isomerism. Okay, so this one will be covered in a bit later. So we have covered this geometrical isomerism. Okay, so what is what is stereoisomerism in general? Okay, so basically stereoisomerism are molecule having the same molecular formula and structural formula in terms of connectivity of the atom. Okay, so this is totally different with the constitutional. Constitutional, they have the same molecular formula but different structural formula. But stereoisomerism, both molecular and structural are the same. It's just that the orientation of the atom in the space, okay, within the molecule are different. Okay, that is in terms of orientation lah. So basically, when when we first look at the molecule, we would say that it's actually the same molecule, but it's not. Okay, dia nampak exactly the same. The chemical formula is the same. The structural formula is the same, but it's different because how it is rotated in space. Okay, so you know that the bond, the atoms, they are all not constantly, dia tak fix, dia tak stay stay dormant in one place. Maksudnya dormant as in dia bukanlah dia apa? Dia duduk diam macam tu. Okay, so they are always in they vibrate, okay, they rotate, okay, the bonds can rotate, the can also apa nama tu, what do we call that, macam spring macam tu. Okay, dia sebenarnya ada movement between the molecule, between the atom and also the bond. Okay, so that's why different orientation when they move. Okay, when they move, somehow it creates different form of apa nama tu, orientation. Bila dia move, dia bergerak. So orientation dia mungkin ni ke atas, and then bila dia move another round, dia jadi dekat bawah. So that creates like new types of molecule. Okay, just perbezaan orientation dia tu saja. Everything is the same, it's just that dia bergerak. Okay, ni dekat atas, kejap lagi dia jadi kat bawah. Itu saja. Okay, so that is called stereoisomerism. So we have two types of them. We have two types of it. Geometrical. Okay, so let's start with geometrical. So this is like a recap. Kita recap dulu, okay? Okay, for geometrical isomerism, there are two rules that you have to comply. Okay, you have to comply with the two rules for geometrical isomerism. First, the syarat or the rules, you need to be you need to have double bond. Okay, you need to have C double bond C, or it can also be in cyclic structure. Okay, you need to have C double bond C ataupun in cyclic form. That is the first rule. Okay, alright. Second rule, dia kena pegang. This one. Each carbon yang held the double bond, okay, or the cyclic structure, should be attached to different molecular weight group of atom ataupun to different group of atom. Different group of atom means it will definitely have different, not necessarily will have different molecular weight. Again, different group of atom not necessarily means it will have different molecular weight. Okay, so that's why maybe they specify even further, dia kata different molecular weight group. So even though group of atom tu dia tak sama, group of atom tu dia tak sama, tapi it may have the same molecular weight. Kan? Macam contohnya kita ada kawan kita ni nampak kurus, kawan kita ni nampak besar, tapi turns out dia punya weight dia sama. Tu maksud saya. Okay, so bila this statement specify different molecular weight group of atoms, it means that doesn't matter whether it is the same group of atom or, sorry, how do I put it? Okay, let's just stick to different molecular weight group lah. Okay, different molecular weight group. Sometimes I would use different group of atom. So different group of atom, most of the time will have different molecular weight kan. Tapi tak semestinya. Okay, tapi nak cakap different group of atom. Ataupun you may also mention in terms of different molecular weight group. Itu syarat yang kedua. Okay, to have C double bond C ataupun cyclic form. Secondly, the C double bond C, each carbon should be attached to two different group of atom. That is the second rule. Okay, if these two are obeyed, that means it will have the geometrical isomerism. The isomers will be in cis or in cis ataupun in trans form. Okay, like for example, this one kan, we have C double bond C. Okay, the first rule is obeyed, tick. Second rule, however, we have to check for each carbon. Okay, so this carbon does not obey the second rule because it is attached to two same group of atoms. So it cannot be this way. Tak boleh macam ini. Okay, kalau dia sama group, that means it will have same molecular weight kan. So this is not allowed for geometrical isomerism. Same goes to this carbon also. This carbon is attached to two same atom, which is hydrogen. So tak boleh, ni tak pas, ini pun tak pas. Okay, so there's no geometrical isomer for this molecule. Same goes to this one. Okay, same goes to this cyclic form. Okay, all right. So cyclic form, you focus on the carbon that is apa nama tu, bearing different group of atom compared to the rest. Okay, dia ada dua carbon. Just focus on the two carbon. Okay, yang pegang group yang berbeza. Contohnya, okay, yang ni kan semuanya H, everything, all of them are hydrogen. Tapi yang ni CH3. Okay, focus on that carbon. Okay, so focus on this carbon, then this carbon you compare or you check on this carbon. Okay, so this carbon is bearing two methyl group, two group of same two same group ataupun two identical substituents. So this is also not allowed. Okay, bila satu je pun tak allowed, so definitely it will not have cis and trans. Okay, dia bukannya okay satu pas, satu lagi tak pas, boleh ada cis and trans. Tak boleh, dia kena both of them should comply with the second rule just now. Okay, alright. So dia tak semestinya side by side. Dia tak boleh, for cyclic form, does not necessarily be the side by side carbon. So it can also be here. Contohnya, so here we have CH3. Okay, and then here we have CH3. Katakanlah this is hydrogen. Okay, so this carbon is attached to CH3 and one other atom is hydrogen. And this, focus on this one. So this carbon, because dia pegang group yang berbeza kan, CH3 and another hydrogen. So for this type of molecule, we have geometrical isomerism. Okay, this molecule has geometrical isomerism. So in this case, it is trans. Alright. Okay. So that is how we determine whether the molecule has geometrical isomerism or not. Okay. Now, since we let's say the molecule has complied with both rules just now. Okay, so how are we going to assign the cis and trans? How are we going to assign this is cis and this is trans? Okay, all right. So you have to identify in terms of the molecular weight. Okay, based on the molecular weight. Okay, so you focus on the double bond. So this is double bond. Okay, so if we were to check lah from the beginning, okay, it has double bond, and then this carbon is attached to one CH3. One hydrogen, so both of them are different, right? Same goes to this carbon, it is attached to this bulky group, and another group is methyl group. So both of this group of atom are different. So these molecules are therefore, this molecule is therefore complied the two rules that we have for geometrical isomerism. Okay, all right, so settle. So now kita nak assign which of this molecule is cis and which of this molecule is trans. Okay, all right. So cis means the high molecular weight or the low molecular weight are located on same side. Okay, take for example. Okay, so if again you are going to focus on the C double bond C. Okay, so you assign for each carbon. Okay, so let's start with this carbon first. Okay, for this carbon, this is high molecular weight, whereas this one, yang CH3, okay, is low molecular weight. Go for each carbon, okay guys? Okay, alright. How about the second carbon here, this carbon? Okay, for this carbon, it is attached to this methyl group and hydrogen, right? So methyl and hydrogen, which one has higher molecular weight? So CH3 will have higher molecular weight. Okay, all right. So, and then this one is lower molecular weight. That is how you compare the molecular weight. Don't compare based on different carbon. Don't compare, okay, this is high molecular weight, this is low molecular weight. Don't do that. That is wrong. Okay, you are going to focus each carbon at one time. Okay, so this carbon, okay, you identify which one is having higher molecular weight. Okay, which one is having, which is higher molecular weight, which is lower molecular weight for that particular carbon. And then only you switch to the other carbon. Okay, you are going to use the same approach that you used for first carbon just now, from the for the previous carbon just now. Therefore, this is cis. Okay, because the high molecular weight are located on the same side. Or you can also refer to the low molecular weight. Okay, the low molecular weight are on the same side. Okay, so for the trans, the high molecular weight, trans means they are on the opposite side. Okay, so this is high molecular weight just now, right? This is low molecular weight just now. With respect to this carbon, this is low molecular weight for the second carbon, and this is high molecular weight for the second carbon. Okay, as you can see, they are at the opposite side with one another. So this is trans. Same goes to the low molecular weight. They are opposite side with one another. Okay, so that is how you determine the the cis and the trans for geometrical isomerism. Okay, all right. So so this is like I've mentioned to you for cyclic last time. Okay, cyclic. We also have cis and trans when it is opposite. Okay, so we focus on this carbon only. The rest kita tak payah concern sangat. Okay, focus on the carbon that bears the different group of atom. Okay, alright. So these two carbon dia pegang two different group. Sini ada OH. Okay, the rest are all hydrogen kan, as you can see. So this one pun ada OH. So as you can see, these OH are in trans form. Okay, because they are opposite with one another. Satu dekat atas, the other one is at the bottom. Whereas cis, it can either be both on top ataupun both at the bottom. So same side. That will be cis. Okay, if you were to use this wedge dengan dashes line, okay, so if we were to represent the trans form of isomerism, we are going to use the wedge and the dashes. Okay, so this is trans. If we were to represent the cis, so you can either use what do we call this, dashes. Okay, both should be dashes or both should be what do we call that, wedges line. Both should be wedges line. Okay, wedges lah, both should be wedges. Okay. Okay, so that is for geometrical. Okay, let's now moving on to optical isomerism. Okay, the second type of stereoisomerism. So what does it mean by optical isomerism? Okay. Okay, so molecules that are optically active. Okay, optical isomerism means molecules that are optically active, which means, okay, they are able to rotate plane polarized light and are known as chiral molecules. So chiral, so what does it mean by chiral? Okay, all right, so in order to have optical isomerism, the molecule need to be chiral. So that is the rule, okay, the syarat that we have for stereoisomerism. How do we know? Okay, katakanlah kan, tadi, how do we know for geometrical isomerism? How do we know that the molecule is considered as geometrical isomerism? We are going to check for the basic one will be, we are going to check for the double bond. And then after the double bond, we also need to check for the group of atom that are attached to the double bond also. Okay, we have to check for that two, we have to consider for that two rules lah. Same goes for optical isomerism. The syarat is to make sure that the molecule is chiral. If it's chiral, then it has this ability to rotate the plane polarized light, or also known as optically active. So this is the rule lah, kena chiral. But the problem now is, what is chiral? Okay, so what is chiral? Chiral molecule, so this, let's look at the second statement that we have here. Chiral molecules, the mirror image of one another, are known as enantiomer. Okay, so again dia tak explain what is chiral molecule. Kejap lagi dekat slide next tu baru dia nak explain what is chiral molecule. Ini dia just dia like inform saja, okay, information kepada kita. So chiral molecule, okay, if the molecule is chiral, that means it will have optical isomerism. Okay, that means it will have isomers. Okay, the isomers is known as enantiomers. Dia ada nama dia lah. Like geometrical isomers just now, dia punya isomers is known as cis. Okay, and cis is isomers to trans. That's the name of the isomerism. But for this one, the name of the isomers is known as enantiomers. Faham? Dia spesifik. Maksudnya when you mention about enantiomers, you akan automatically understood that we are talking about optical isomerism, not about cis and trans. Faham? Not about geometrical isomerism. We are talking about optical isomerism. That's why dia tak boleh cakap isomers. Bila kita cakap isomers is like the general term that we use to describe more on the constitutional isomers lah, having the same chemical formula but different structural formula. Kan? That's the general term of it. Tapi for optical isomers kita specify kan. Okay? So the isomers is known as enantiomers. So how do we draw these enantiomers? So it's actually the mirror image of the chiral molecule. Okay, the chiral molecule. Don't worry. Okay, we will explain. I will explain further on what is chiral. Okay, and how do we determine the mirror image of this chiral molecule. So dia ada syarat jugalah. Chiral ni what is meant by chiral. Okay, all right. So let's look at the experiment, the simple experiment that we have here. Why is it called optically active? Okay, so ni kita ada light source, the bulb, menthol. So basically we have this polarizer. Okay, so kita ada lampu kan, patutnya direct source here. So as you can see, we have katakanlah kita ada straight line. Okay, this straight line of light. So this is where we place the molecules that is chiral lah. The chiral molecules, we place it in here, and this molecule has the ability to polarize. Maksudnya dia rotate the light tau. Polarize means dia mengubah apa nama tu, bentuk asal light tu. Okay, initially it is straight, but after a while dia get rotated. Nampak tak? Dia terpusing dekat situ. Dia get rotated. Dia become ada angle lah dekat situ. Okay, when this light pass through this analyzer and finally reach the observer's eyes, okay, the observer will observe the rotated light. Dia akan nampak rotated light. So initially dia punya tu straight, tapi bila dia go through this tube that has the chiral molecule, so the chiral molecule has the ability to rotate the light and cause the observer to see the rotated light. Maksudnya the modified light tadi. So that is called optically active. Okay, that is called optically active. So this molecule is considered as chiral. Okay, chiral. Okay, why does this molecule is called chiral? Chiral is carbon having different group of atom, 4 different group of atoms attached to it. Tu chiral. Nanti kita akan tengok lagi. Tapi saya bagi awak overview lah. I mean brief idea what chiral is. Okay, what chiral is. So what is chiral? Chiral means the carbon is attached to 4 different group of atom ataupun 4 different atom. So that is what we call chiral. Okay, as you can see from this diagram here, we have carbon at the middle. So this will be called stereo center. This is the center, the carbon that is chiral. If we have chiral carbon in a molecule, then we could say the whole molecule is chiral molecule. Okay, so kita kena identify each of the carbon tu. We have to identify whether we have chiral carbon in the molecule or not. Tu kita kena identify, kena check setiap satu. Apa syarat dia? Carbon tu mesti pegang 4 different group of atom. That's why they assign color, different color ni macam ni. Color kuning, color green, blue and red. Shows that all of them are different from one another. Okay, so this is what we call chiral. Okay, so how do we draw these isomers? Kita dah identify, okay, this molecule is chiral. So how do we draw the isomers of this molecule? This isomers is known as enantiomer. Okay, the isomer is known as enantiomer. So what we need to do is we have to draw this dashes line. This dashes line is actually representing the mirror. Okay, so simple saja. So you basically draw the mirror image of this molecule, guys. The mirror image of this molecule. Okay, so as you can see, atas dia sama. Okay, this one should be side by side. Number 2, they should be side by side. And then number 1 memang dia straight line. It should be the same. 4 pun duduk dekat the same distance lah from here, okay, to here. So dia sama. Okay, this one should be side by side. You imagine you are facing a mirror. Okay, you are facing the mirror and then you duduk sebelah-sebelah macam tu. Alah dia macam ni. Like your hands kan. This is another example that maybe it will be easier for you to understand. Okay, other than organic compound, okay, we also have chiral material, okay, atau chiral things that we have around us. For example, our hands, our right hands and our left hands, okay, they are enantiomers to one another. Okay, so our hands, okay, in general, kita punya satu tangan kita, this is also chiral. Okay, our hand is also considered as chiral. Because why? Because we have 5 fingers, right? So all these 5 fingers are different in length. Kan, ibu jari kita gemuk sikit. Tapi dia duduk dekat paling hujung, belah kiri. And then kita ada jari manis, and then jari tengah, jari kelingking, jari ni second last ni. Different in length. So these are all chiral, guys. Okay, so dia punya tangan kanan kita, dia punya isomers dia adalah tangan kiri. Bila you place dekat mirror, tangan kanan you akan nampak tangan kiri. Okay, so nampak tak? Dia side by side ni. Ibu jari kita belah kanan and ibu jari kita belah kiri. Okay, they are placed side by side with one another. So this is the mirror image kanan to kiri. Okay, ni adalah contoh what do we call that? Chiral. Okay. Okay, like I said just now, so they are attached to 4 different group of atoms. So then this is called chiral carbon. So this is the original molecule. So how would you draw the enantiomers? So basically, you have a mirror. You imagine you have a mirror and you reflect that original molecule. Okay, and the mirror image will be the enantiomers of the original molecule. Okay, all right. So it's like the mirror image is rotated 180 degrees. So like I've mentioned to you just now, the left hand, the right hand. Okay. Okay, one of the characteristic of this optical isomerism is that it is non-superimposed. Non-superimposed, okay? It may look the same, but it's not the same. Tangan kanan kita dengan tangan kiri kita nampak sama, macam exactly the same. Tapi dia berbeza sikit. Okay, dia punya karakteristik dia sama, but it is not superimposable. Kalau everything is the same, semuanya everything sama, it should be impossible. Okay, it should be superimposable. Maksudnya boleh di-overlapkan, it will be exactly the same. Macam kalau kita nak ubah apa nama tu gambar ke apa kan, yang orang duk cakap superimposable tu kan. Sebab orang tak boleh nak differentiate ini betul ke tak. Itu maksudnya ada karakteristik of superimposable. But our hands, those are chiral things are not superimposable. Superimposable ni dia macam tricky sikit. Dia nampak sama tapi dia sebenarnya tak sama. Alright, dia macam ni. Bila you nak impose, you jangan buat macam ni. Bila macam ni, you nampak dia macam superimpose kan. You ambil tangan kanan, ambil tangan kiri, you rapatkan macam ni. Nampak macam dia superimpose. Ini karakteristik of superimpose. Nampak? Bila dia overlap atas dan bawah sama. Tapi bukan macam tu cara nak superimpose kan. Dia macam ni. You ambil this right hand, you angkat, you letak kat atas dia. Bukan you macam ni kan dia. Okay? You angkat, letak atas tangan. Superimpose kan? Angkat, letak atas dia. Tempel. Kan? Nampak tak? Dia overlap tak? Tengok ni tangan kanan mana ada ibu jari kanan, mana ada overlap dengan ibu jari kiri. Dia tak overlap. So this is what we call non-superimpose. Okay? Kita nampak dia sama as if macam it can be superimposed but it's not. Can you guys see? Nampak tak tangan saya ni bergerak-gerak? Nampak kan? Clear kan? Ke saya clear Dia nampak Ke macam saya ke atas sangat ke bawah sangat ke tepi ke tak? Okey.
Okey je madam.
Okey Okay. Right, so kalau tak faham apa maksud chiral ni, tengok tangan. Tengok tenung tangan. Ini chiral. Okay, our hands are considered chiral. So kanan adalah enantiomers kepada kiri, kiri adalah enantiomers kepada kanan. Okay. Chiral molecule has stereocenter known as chiral or asymmetric carbon. Okay, alright. So chiral carbon is sp3 hybridized. Okay, it must be in sp3 hybridized. That means the carbon need to have all single bond. So the carbon cannot have double bond or even what else triple bond lagi lah tak boleh kan. Sebab dia mesti in sp3 form. In order to have sp3, all the bonds need to be single bond. So tak boleh ada double bond. Okay, you have to check for that carbon. So if dia ada double bond, that means they're totally out lah. So it must be in sp3 form, hybridized, and has 4. See, nak dapat sp3, baru ada 4 bonds. Okay, has 4 different atom or groups of atom attached to. Contohnya this one. Okay, this is a chemical formula. Okay, so we have this carbon. So this carbon is known as chiral carbon. Why is it called chiral? Because it is all the 4 bonds are attached to 4 different group of atoms. So we have CH3, we have hydrogen, we have OH, and we have C2H5. Okay, alright. So how do we draw this enantiomer ataupun the isomers of this chiral molecule? So you draw the dashes line. So this dashes line represent the mirror lah. Okay, represent the mirror. Okay, and then you draw exactly the same. You have C kan? Okay, it's just that you have to make sure dia punya tips dia adalah make sure that this side, okay, should be side by side with the mirror image, with the group, okay, that is attached to the mirror image of this molecule. Dia kena side by side macam tu. Okay, dia punya dashes, everything should be the same. Dia attach kepada orang yang sama. Dia bukan berubah pun, dia sama. Nampak? Exactly. Dashes on the original molecule must be attached to C2H5. Same goes to pada mirror image. Is also attached to C2H5. The wedge line is attached to OH. See? Original pun wedge OH. Okay, tapi dia nak yang ni nanti you nak tukar jadi solid line ke apa ke tu doesn't matter. Like I said, dia sentiasa berputar, dia sentiasa berrotate ataupun it is always in rotating motion. Okay, so ada student mungkin dia buat OH, dia buat apa nama tu, this one CH3, dia buat dekat sini CH3, kat atas ni OH. Doesn't matter, tak kisah. Sebab kita akan based on your original solution and then you pandai tak nak mirror image of the original molecule. Okay, so kita akan based on your original molecule. Sebab different student may have different representation of the molecule. Okay, alright, so that means contohlah, ini macam quite obvious kan? Oh, obvious lah because the carbon is attached to 4 different group. Okay, alright, so normally normally the question would ask, it would give you this chemical formula ataupun it will give you, if this one, okay, saya transform into chain punya molecule, okay, chain. Ini dia dah fokus pada this carbon. Okay, the original version of this molecule is like this. Okay, so this carbon is attached to hydrogen, right? Okay, it is also attached to CH3, right? Okay, and then we have OH attached to the carbon. Okay, so C2H5, dia ada 2 carbon lagi kan? Maksudnya C2H5, maksudnya dia compress lah tu. See? Dia sebenarnya macam ni, asal dia macam ni. This is the original molecule. Okay, so how it is transformed into this? Okay, alright. So first step, bila you are given this molecule, this type of molecule, you can identify the chiral carbon that we have in the molecule. Sometimes it may have chiral carbon, sometimes we just don't have chiral carbon in the molecule. So you can identify lah. Okay, what is the rule that we have to comply with? Dia kata, satu rule je, kena pegang 4 group of atom yang berbeza. Okay, so we have to check for each of the carbon. Sebab all of them may have the possibility to become chiral. Okay, kita check for this carbon, the first carbon here on the left. Okay, so this carbon is obviously attached to 3 same hydrogen atom, 3 hydrogen atom lah. So this will definitely not be chiral. Okay, how about this one, this carbon yang hujung belah kanan pula. Is it chiral? No, this is not chiral because it is attached to 3 hydrogen atom. How about this one? Is it chiral? No, it's not chiral as well because dia pegang 2 hydrogen atom. Dia tak boleh sama. How about this one? Okay, alright. Dia pegang hydrogen, dia pegang OH, dia pegang, you mungkin akan nampak, oh ni pegang, ini attached kepada C. This is also attached kepada C. So kalau you based on that, you tak akan dapat chiral sampai bila-bila. You kena consider the carbon as a group of atom. Okay, alright. So this carbon is attached to this group, right? So this is what we call CH3. And this carbon is attached to this whole group here. Yalah, walaupun this one is not directly attached to this carbon, yang hujung ni not directly attached to the carbon, but when we compress this, okay, kita kumpulkan dia akan jadi a group of atom, right? So this group of atom is attached to this carbon. So bila kita compresskan dia tu yang kita dapat C2H5 tu. Okay, so nampak tak different group of atom. So yang ni bukan chiral but this one is chiral. Okay, so you bukannya tengok dia attach pada carbon, oh sama. No, bukan macam tu. Bila carbon you kena group them. So group them as one group. Okay, you kumpulkan, you dapat C2H5. This one CH3, this one C2H5. It's not the same kan? So all of them are different. So it's considered as chiral. Okay, simple. So you have to check for each of the carbon that are present in the molecule. Okay, the importance of optical isomerism. Okay, the importance of optical isomerism. In 1950s and 1960s, okay, there was a drug that is known as thalidomide. Okay, this was sold in 1950s and 1960s as anti-nausea for pregnant women. So this thalidomide somehow is very helpful in overcoming the nauseous feeling that normally pregnant women would experience. Okay, so this is very helpful. However, it was withdrawn from the market in 1961 due to its teratogenicity. Teratogenicity ni is the what do we call the toxic or the ability to cause defect, severe defect in babies. If we are talking about thalidomide, so this thalidomide dia ada effect of teratogenicity to the babies because it will form deform babies. Okay, deform ataupun birth defect pada babies. Because why? Thalidomide turns out to be chiral molecule. Okay, it's a chiral molecule. Okay, we focus on this. This is the structure of thalidomide. Okay, of course it is more complicated than the one that we have in example just now. Okay, the cyclic and whatnot. Okay, just to highlight this carbon here. This carbon is considered as chiral. Okay, as you can see, for this first molecule, okay, the wedge, okay, the wedge bond is attached to the nitrogen. For this second molecule, we have the same carbon, but now the rotation is different, right? So the orientation is different. So this is using dashes line. Okay, maksudnya it is now at the back ataupun this one in front. Okay, going to us. So it may look the same kan, exactly the same. It's just that dia punya rotation, tapi dia punya effect is very, very severe. Okay, so that is why it is very important for us to determine this optical isomerism. Don't take it as something that is light matter lah. Okay, it's not light. It's in fact very, 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 very dangerous and very, very severe lah. Okay. So if it is in this form, and then it can become as sedative ataupun tonic, okay, which can serve as anti-nausea just now, okay. But if it is in this form, second molecule ni, it is teratogenic, which is very toxic and it causes birth defect to the babies. Kesian kan? So as isomers, okay, so this is another term that you will learn later, okay, if you would like to study in detail for chemistry, okay, in chemistry. So as isomers is how we differentiate the enantiomers, okay, but we are not going to cover this in our syllabus. So we have S dengan R to differentiate original dengan yang dia punya mirror image. Okay, macam tadilah contohnya. Cause horrible birth defect ataupun deformed limbs. Okay, dia tak fully developed. So 10,000 deformed babies were born, okay, during that time. Then only agaknya baru dia discover that it is due to this drug. Okay, barulah dia withdrawn in 1961. Okay, so this was what happened lah last time. So jangan ingat nampak beza, alah tak ada beza sangat lah. Kalau setakat makanan ke apa tak apalah, tapi ubat, when it comes to ubat, medicine, drugs ke whatnot, yang very ni, you don't take it lightly lah. Okay, you have to confirm because it will create different effects. Even though it may looks the same it may look macam tak membahaya tapi sebenarnya membahaya. Okay, alright. Alright, so 2-hexenol, checkpoint 5. This is related to geometrical isomers. Okay, I have asked you to complete this one, this checkpoint before, because this one is about geometrical isomers that we have learned earlier, which was last week. Tadi kita cover untuk optical isomerism. So patutnya you guys dah complete dah this checkpoint 5. Okay, alright, so let's go through the answer. 2-hexenol can exhibit stereoisomerism. Okay, so stereoisomerism can have two types, right? We can have geometrical, which is a cis and trans, and we can also have the optical isomerism. Okay, which represent the chiral molecule. Chirality of the molecule. Okay, so bila dia cakap stereoisomerism here, it is like I would consider this as general lah. Okay, because it doesn't specify whether it is geometrical or optical isomerism. So it's your part, it's your responsibility to determine what type of stereoisomerism for 2-hexenol. Okay, alright. So yang lelaki thing is dia bagi not only dia name the compound, dia bagi juga the the structural formula in condensed form. Okay, and it is obviously shown here that we have double bond there. We have double bond. So it is most likely to have geometrical isomerism, most likely, but we have to check with the tools. And it can also be, okay, dia tak semestinya bila ada geometrical, dia tak akan ada optical isomerism, because it's, as you can see, we have a lot of carbon there that we can check whether it has chiral carbon or not. Boleh ada dua-dua at once. Boleh, sebab dia ada double bond, and also other carbon that may have the possibility to become chiral. Whatever it is, we have to check. Okay, tapi paling obvious is geometrical lah. Geometrical nampak dah ada double bond kat situ. Cuma nak check ada tak cis and trans. Okay, so first you have to draw the expanded structural formula for 2-hexenol. Okay, alright. So this is how you should be drawing it. CH2. Okay, alright. H2 and then ni OH. Okay, this is OH. Make sure that it is, oh terkejut, Allahu Akbar. Okay, make sure that the carbon will always have 4 bonds. Okay, alright. This carbon, this one settle, and it is attached to this carbon. Okay, alright. This carbon has 1 hydrogen and it has double bond there. Okay, done with this one. Okay, next we have this carbon, the third carbon. This third carbon has 1 hydrogen. See? And then settle for this one. So we have CH2. Okay, settle. Next we have another CH2. And then lastly CH3. Okay, alright, check dekat double bond ni cukup tak bond dia 1, 2, 3, 4. This bond, this carbon also 1, 2, 3, 4. Okay, alright, settle. Okay, so this is the expanded version of 2-hexenol. Settle for A and then B. Name the type of the isomerism that 2-hexenol will exhibit and draw the isomer. So this is the question that I have highlighted just now. Okay, the type of isomerism. Is it geometrical or is it optical isomerism? Okay, let's check for geometrical isomerism lah. Okay, let's check for geometrical let's check for optical isomerism first lah. Okay, because we just have to check whether the carbon has chiral carbon, the molecule has chiral carbon or not. So we have to check each one of them. This will not definitely be chiral. These two will not be chiral forever because it has double bond there. Okay, alright, so we check for For this carbon, how about this carbon? Okay, it is attached to 2 hydrogen. So this is also not chiral. How about this one? Also not chiral. This is also not chiral. And this also not chiral. So as you can see, we don't have chiral carbon in this molecule. Okay, alright. So that tepi definitely bukan optical isomerism. Definitely will not be this isomer. Okay, so let's check for geometrical isomers. Okay, so let's target the double bond only. Okay, so this carbon here, it is attached to hydrogen and also attached to this group, right? You combinekan dia, you akan dapat this group lah, which is different kan, hydrogen dengan this group, this carbon, hydrogen dengan carbon is already different lah kan. Okay, so this one pass. Syarat untuk geometrical, okay, alright. Secondly, this carbon yang double bond ni attached to hydrogen and then another carbon ataupun this group. Kan different kan? So pass juga. So dia ada geometrical isomerism. So the answer will be, the type of isomerism is geometrical. So soalan tanya, draw the isomers. Okay, draw the isomers. So how will you draw the isomers to represent the cis and trans? And how will you represent using this type of molecule? Maksudnya cara penulisan yang begini, yang macam ni. Yang fokus on the double bond C. Okay? Macam itu. Tak nak buat macam straight macam tu. Okay. So this is the tips. Yes.
Yang tadi kan dia geometrical kan, tapi kita nak kena spesifikkan tak cis ke trans.
Sorry, tak clear.
Yang tadi kan geometrical kan, jadi kita kena spesifikkan tak cis ke trans.
Tak clear juga. Geometrical tadi, saya dengar geometrical, lepas tu dia dah macam
Hello?
Ya.
Madam, nak tanya tadi kan dia geometrical kan, so kita kena spesifikkan tak dia cis ke trans.
Kenalah. You kena, ni kan dia cakap draw the isomer. So you have to draw in terms of cis and trans. Okay? So you need and will exhibit and draw the isomer. So definitely you have to show whether you have to show the cis and trans structure. Okay, cis and trans structure. So how will you draw? Saya punya question is, how will you draw the cis and trans? Macam bentuk yang kita dah lalui contoh tu. Bukan macam ni. Jangan buat ini yang normal lah. So kita nak kena go for target for the double bond. So my tip, so this is my tips, okay? Alright, you target for the double bond. You do for the double bond first. C, double bond C. And then next you buat macam ni. Kali lain lah. Okay, you buat macam tu. Ini kan trigonal planar, ni nampak? Trigonal planar. Okay, so you buat macam ni. Okay. Apa you buat ni sebenarnya benda yang sama as this one, expanded. Cuma you sengit kan. H ni you sengit jadi ke sini, yang ni you bawa turun ke sini. Macam tu. Kan? See? Yang ni you kumpulkan. Sebab the target is the double bond kan. Okay, you have CH2 there. Then OH. See? Settle lah. And then how about this one? This C here. You have hydrogen there. And then this, you kumpulkan lah. Compress kan. Okay. So you have CH2. Condense kan. CH3. Dah siap. Okay. Is this cis or trans? So this is cis. Because you can identify the high molecular weight dengan low molecular weight. Okay. For this carbon, hydrogen is low molecular weight, right? This one is high molecular weight. For this one, this carbon, this is low molecular weight. This is high molecular weight. So this is cis. Okay, and then it's given to you already, the name. Okay, so you cis and then you tambah guys, 2-hexenol. Sebab dia dah bagi kan, you tambah cis dekat depan nama tu. Cis 2-hexenol, that's the name of it. This is only for cis. How about you draw? How about trans? Okay, my tips is to, okay, you nak draw for trans kan, it should be the opposite side kan. Okay, you retain one carbon. Okay, katakanlah saya suka retain this carbon. Maksudnya I won't change or I won't modify this carbon. I will only change this second carbon that doubly bonded to one another lah. Okay, alright. Saya alter yang bawah naik atas, yang atas turun bawah. Ni. Itu saja. So, it will become like this. Yang ni saya maintain hydrogen. This one tadi CH2OH just now. Okay. Ni pun sama. Maintain dia punya bond tu. Cuma ni tadi turun bawah. Hydrogen turun bawah. Atas tu CH2, CH2, CH3. Okay. So ni dengan this one kan. High molecular weight. So it is trans. Trans 2-hexy. Okay. So you dapatlah bentuk macam yang kita dah buat in previous slide just now. Okay. Ada question please ask. So these are the answer for A and B. Okay, alright. Question 2, checkpoint 5. State whether each of the following pairs is isomers or not isomers. Okay, guys, give me the answer. Okay, A, is it isomers? We have geometrical isomers for A.
Yes.
Are you sure? How about the rest?
No, madam.
Sorry? Yes or no?
No.
No. Okay, so we have yes, we have no. Okay, how about others? The rest?
No.
No.
No, madam.
Okay, alright. So the answer is no. We don't have isomers. We don't have geometrical isomers for this one. How do you check? You're gonna check. Okay, you cannot just simply base, oh, double bond. Okay, confirm geometrical isomer. Not necessarily. Okay, double bond is one of the syarat. So dia ada syarat kedua dia kan. You kena check. Okay, this carbon must, each of the carbon yang dalam double bond tu must be attached to two different group. Okay, go for this one first. Go for one by one dulu. Go for the first one. Okay, kalau yang saya bulatkan ni. So it is attached to one group, methyl group, and then another group is, another atom is hydrogen. So it's two different ni kan. This one pass. Dia okay. Dia lulus. How about the second one? Kena check both. Kalau salah satu ni tak lulus, dia reject. Ni attach kepada dua benda yang sama. So tak boleh. Okay. So setakat kita nak draw cis ke trans ke, boleh je draw. Tapi dia possible tak? Is it possible? Kalau ni contohnya, kononnya macam kita draw dia, ni trans kan? Macam CH3, H. This is trans, this is cis. Tapi in the first place, ada ke cis trans untuk this molecule? The answer is no. Tak ada. So tak payahlah nak buat cis and trans. Okay? Alright, how about B guys? Do we have cis and trans for B? Is it isomers to one another? B.
No, madam.
Okay, B pun sama. No. Because why? Nampak this carbon is attached to CH3. Another CH3. Tak boleh pegang group yang sama pada satu carbon. Out. Okay, how about C? Ada ke tak ada?
Yes.
Okay, you check. C ada H, CH3. Okay, ni lulus. This one dengan this one. Oh, lulus juga. Okay, ada. How about D? Okay, kalau, if we have, dia pass, dia ada geometrical isomerism, so we can determine. So this is in transform. Because the high molecular weight, this is low molecular weight, this is high molecular weight, this is low molecular weight. Okay, you kena check for carbon yang sama tu high molecular weight and low molecular weight dia yang mana. Jangan compare ini dengan ini. Jangan buat macam tu. Okay, you identify dulu high molecular weight dengan low molecular weight for each carbon. Then baru you determine whether it is cis or trans. So this is trans, this is cis. Okay. Okay, how about D?
Yes.
Do you have geometrical? Yes.
Yes,
The answer
madam.
is yes. Okay. Alright, good. The answer is yes. So this is trans again. Okay, kalau dah laju, you dah tahu, you laju je, you boleh tahu. Okay, kalau slow, tak apa. It's okay as long as it is correct. Okay, take your time as long as it is correct. Nanti you practice lama-lama, you dah pro lah. Beginner kan, amateur kan, kena buat style amateur. Okay, start slow. Okay, so this is okay, ini you have to be careful Kalau kalau carbon dengan hydrogen tak apa, it's okay. Tapi kalau Cl ni dia punya molecular weight dia 35.5. You kena check with this one. Okay. CH2, CH3. So this is 12, 24. 24 plus 5 is like 29. Kan? 29. So ikutkan this is high molecular weight, this is low molecular weight. Okay guys? So itu maksudnya in terms of molecular weight. Low molecular weight, high molecular weight. So with respect to Cl and for this carbon, Cl is having higher molecular weight. This one is lower molecular weight. So kena be careful kalau dia involve non-carbon punya elements. Macam bromin kan. You jangan simply, nampak carbon ada banyak. So dia confirm dia high molecular weight. Not necessarily. Tengok dia compare dengan siapa. Bromin kan. You pergi refer molecular weight for bromin berapa? 70 something. Okay. So please be careful on that. Don't just simply, banyak carbon ni confirm dia high molecular weight. Not necessarily. Okay. Alright. So you kena refer to the molecular weight. Okay, checkpoint 5. Choose cyclic compound that exhibits cis and trans isomerism. These are the cyclic compounds. Again, we can have geometrical isomerism for cyclic compound. Okay, can it either be cis or trans? We can have cis and trans isomers lah. For each dash, draw the cis and trans isomers. Use wedge dash projection to support your answer. Okay, before we will go for the projection ataupun nak draw the cis and trans, kita kena identify dulu in the first place, do we have geometrical isomers for all of these molecules? Jawab soalan pertama tu dulu. Kalau ada, baru kita boleh go for cis and trans. If we don't have the geometrical isomerism, if the molecule does not comply with the two rules for geometrical isomerism, so tak payah mimpi lah nak ada cis dengan trans. Okay, alright, so let's check for A. Do we have cis and trans for A, guys? Come on, guys. Does molecule A have cis and trans?
Yes,
No,
madam.
madam.
Okay, kita ada yes, kita ada no. Okay, lagi. The conflict kat situ. Come on, guys. How about the rest?
No.
No. Okay, baru 3 orang ni. Jawab je. Nanti kita check lah.
Yes.
Tapi sebelum jawab tu fikir dulu Jangan main tibai je. Yes, ada yes. Okay. Lagi?
Yes, madam.
Yes. Yes.
Yes, madam.
Yes.
Yes, madam.
Yes, madam.
Yes. Okay, yes lagi banyak daripada no. Lagi.
Yes, madam.
Yes. Okay. Lagi? Maybe lagi 2.
Yes, madam.
Yes. One more.
Yes, madam.
Right. Okay, yes. So majority of you answered yes based on siapa yang responded just now lah. Okay. Alright. So for cyclic, basically dia punya rule sama. It's just that for cyclic compound, the C double bond C is not applicable. Kan? It's not applicable. For cyclic, we don't have double bond. So the rule number 1 is not applicable. Okay, it's the rule number 2 is still applicable. Okay, so focus on the carbon. Okay, so this is a carbon that holds a different group. Because yang lain sebenarnya, ini kemahiran mengidentify group yang ada pada carbon. So this is skeletal form. This is not entirely skeletal. This is mixed. Dia ada skeletal dengan dia ada condense. Okay, alright. So sebenarnya dekat sini ada hidrogen. Okay, ataupun selalu kalau kita buat macam tu kan dia atas dan bawah hidrogen. So ni sebenarnya hidrogen. Okay, yang kita tak tunjuk, yang hidden lah. So yang kan saya kata go for the carbon that attached to different group of atom. So kita ada this carbon and this carbon. Okay, sebenarnya lagi, berbanyak sebenarnya, you kena tahu lagi yang kan kena ada 4 tangan kan, each carbon should have 4 bonds. So one of the bond is attached to hydrogen. Okay, it's attached to hydrogen. Same goes to this one, hydrogen. Kan? Kita nak check rules yang nombor 2 yang apply to cyclic tadi. So this carbon mesti pegang pada 2 group yang berbeza. So 1, 2, dua-dua berbeza. So dia pas. How about this carbon? Dia pegang hydrogen, dia pegang methyl group. So dua-dua berbeza. Pas. Dia tak mestinya kena duduk side by side. Not necessarily. As long as the carbon is in the cyclic form. Dia boleh duduk sebelah-sebelah ataupun dia boleh duduk far apart, jauh. Boleh, tak ada masalah. That's why saya kata focus on the carbon that hold ataupun that bears the different group of atom. Okay, so dia comply dengan syarat dia. So A is having cis and trans isomers. Itu jawapan dia. How about B? Do we have cis and trans for B, guys?
No.
Okay, so this is quite obvious. So this C, so this C yang bawah ni pas, yang ni tak pas. Because it is attached to 2 hydrogens. Okay, how about this compound C?
Yes.
Kurang aja yang jawab, yang lain?
Yes, madam.
Yes.
Madam.
Okay, yes, ini tak. Okay, D.
No.
No.
No you nak compare dengan mana-mana pun tak kisah. Ini carbon ni confirm lah. Okay, dia sendiri dah tak lulus kat sini. Dah tak comply with the rules. Sebab dia attached to same group. Okay, tak payahlah tengok yang lain. Yang ni pun sama. H. Yang ni pun H.
Madam.
Right.
Madam.
Yep.
Apa maksud yang bold tu? Yang garisan bold tu.
Garisan bold?
Yang terang tu hitam.
Yang ni? This one? Maksudnya tak ada apa representation ni. Okay? Dia just basically dia boleh je represent. Mungkin dia nak buat 3D kot, tapi this is not entirely 3D. Okay, dia tak entirely 3D. Dia ni campur kan. Macam ni we have skeletal and we have condensed as well. So dia ni mungkin nak 3D tapi tak entirely 3D. Kalau pakai 3D kita kena pakai wedge dengan dashes tu pula kan. So saya rasa this is not, dia tak represent anything lah. Okay? Tak represent anything. as apa nama tu, my current punya knowledge, as of now saya rasa this does not represent anything. Okay, right. Okay, so lagi satu, lepas you dah determine ini tak, okay, lepas you dah determine dia ada cis and trans, you have to draw using this wedge dash projection to represent the cis and trans for A and C. Okay, alright, so for A and C, this is for A. If you are going for cis, that means you can either use wedge lines or dashes line. Okay, you tak payah ubah apa-apa dia punya CH2, CH3 ni. You do not have to change anything. You just use, just now dia pakai apa just? Solid line. Ni kita panggil solid line. Okay, you transform into wedge. Kalau dia cis, same side kan? So maksudnya you should be using wedge ataupun same wedge line or same dashes line. If you are representing trans, maksudnya salah satu mesti pakai wedge, the other one mesti pakai dash. Okay, you can either use this one as wedge ataupun this one as dashes, then this one as wedge. Okay, so this is cis, this is trans. Faham ya? Okay, so this is question C. Cis and trans. Preference lah, just kalau you, that means if you go for any of this answer, you still get marks for your answer. Okay? Checkpoint 6. Identify the chiral carbon atom present in the compound below. For each that does, mark the chiral carbon with an asterisk. Describe the stereoisomerism present in the structure A. Guys, do. Okay, focus on A only. Okay, not for B and C. Okay, but we have to identify whether we have chiral carbon in A, B or C. We have to check. Okay, alright. So ni you ada banyak carbon kan? You kena check lah. Syarat untuk jadi chiral apa? Dia mesti pegang 4 group yang berbeza. Yang ni yang saya kata tadi, you kena compresskan. Kalau you just refer, pegang ni carbon, ni pun carbon. Sampai bila-bila takkan chiral macam tu. Okay? Alright, so let's go for A. Okay, A ni kita nampak ada double bond. So kita mesti bear in mind that, is there any possibility ada possibility tak this molecule might have geometrical isomerism? Yes, we have that possibility. We will check on them later. Maybe soalan ni, dia fokus on A, mungkin target dia nak go for that one. Kan saya pernah cakap, dia mungkin ada dua-dua type of stereoisomerism in one molecule. Okay, in one molecule, it may have what do we call that? Geometrical isomerism and also optical isomerism. Okay, so let's just check the chirality of the carbon first lah. Okay, so let's just check for A. Do we have chiral carbon or not? No. How about, this is carbon number 1, carbon number 2. No, because it is double bond. Okay, this is also rejected. How about this one? Is it chiral? Okay, let's check for this one. Ni paling obvious kan? This is not chiral lah. Sebab dia attached pada 3 hydrogen. How about this one? This last one yang dekat tengah ni. Is it chiral? What do you guys think? Is it chiral, guys? This carbon. Is it chiral?
No.
Are you sure? Why do you say this carbon is not chiral? Kenapa? Kenapa kata no?
Ya, madam. CH2.
Kalau you just check, macam saya cakap, kalau you check kepada C, dia attach pada C kan sama. Tak boleh lah. C kan, ni C, this is carbon. Kalau macam tu sampai bila-bila kita tak akan ada chiral. Okay, you bukan check macam tu, you kena check group of atom. So, yang lain tu saya tanya ada chiral ke tak? Nampak tak? Ni chiral ke tak chiral ni? Rasa-rasanya.
Chiral.
Yang lain? Nampak tak kechiralannya?
Nampak.
Nampak, madam.
Okay. Alhamdulillah kalau nampak. Okay, alright. So, kita target this carbon. This, okay, paling obvious dia pegang H, dia pegang CN. This is already two different group of atom. And another tangan dia tu attach kepada this one. This is kalau kita compress, dia jadi CH3, guys. And this thing, kalau kita compresskan dia, kan nampak bulky group kan. This is definitely different than CH3. You compresskan dia, you akan dapat macam ni. CH, double bond CH, CH3. Ataupun you tak nak tunjuk double bond pun tak apa, abaikan. CH, CH, CH3. See, all of them are different. So, this one is chiral. Okay, kita ada satu chiral on A, in A. Okay, how about B? We have to check. Okay, this is not chiral, this is not chiral. How about D? Kejap, kita check yang paling senang, yang nampak obvious pegang hydrogen kan. Not chiral, this one not, this is nitrogen. This carbon has double bond, not chiral as well. This, we have two hydrogen there, not chiral as well. How about this one? Okay guys, nak tanya. This carbon here, is it chiral or non-chiral, guys?
Not chiral.
Okay. Kenapa dia not chiral?
Dia dua CH3.
Yes. Okay, very good. Okay, you jangan ingat hydrogen je manjang You kena compresskan. You compresskan, okay, you notice that this one is CH3. But this one also is CH3. Betul tak? So CH3, CH3. They are the same group. So tak chiral. So this is not chiral. Okay. So B has no chiral carbon. Okay, let's check for C. Not chiral, not chiral, not chiral. This is definitely not chiral. How about C? Is it chiral? Yes, it's chiral. Okay, this is when you compress all of this into CH3. When you compress this, you're going to have C2H5. Okay, ataupun you boleh buat macam ni. Kalau you boleh buat C2H5 or CH2, CH3. Okay, and this one you compile. This is aldehyde, not alcohol. So if you were to represent aldehyde, it should be CHO, not COH. Okay, don't do this. This is for alcohol or hydroxyl group, but this is for aldehyde. So H should be in the middle. Therefore, and then another one is hydrogen. So this is chiral. Okay, all right. So last question: describe the stereoisomerism present in the structure A. So we know that in A we have optical confirmed because of the presence of chiral carbon just now. Now we have to check for geometrical. Do we have geometrical isomerism for this one? You guys rasa ada tak geometrical for this isomer for A, guys? Ada ke tak ada?
Ada.
Ada ke tak ada?
Ada, madam.
Nampak tak? Yang lain nampak tak? Dia ada geometrical isomerism. Nampak ke tak nampak? Dia ada cis dengan trans.
Nampak.
Ya. Okay, dalam satu molekul ada dua types of isomerism. Okay, nampak tak? Okay, fokus. Dia ada double bond. Pass. Rule number 1, pass. Rule number 2, the carbon must be attached to two different group. Okay, this carbon, the focus will be these two. Okay, it's attached to hydrogen and it is attached to CH3. So different group, right? So pass group, carbon number 1 pass, carbon number 2 hydrogen, and this bulky group. Two different group of atom. Pass. So dia ada geometrical. Okay, all right. Okay, so A kita ada just now, B tak ada no chiral carbon. This is the answer, okay? C ada yang dekat sini. Okay, ni yang soalan nombor 2. Compound A has geometrical isomerism 2 beside optical isomerism. So you would have to draw the cis and trans form of the geometrical just now. You dah determine kan, ada kan? So you transform in terms of cis dengan trans. Okay, so this is cis. This is trans. This is in terms of optical isomerism. So how will you draw? How will you transform this? How would you transform this? This is the this is the stereo center just now, and this is the chiral just now. Okay, so macam mana you nak transform this dalam bentuk 3D just now? Okay, saya punya suggestion, you go for the carbon, you go for the chiral carbon. That is our focus. Macam tu. Okay, alright. So buat 3D lah. It is advisable for you to draw in 3D form macam ni. So dia ada dashes kan. Alah, tersengit sikit, sorry. And then you ada wedge. Then you ada solid line. Another solid line, right? Okay, so kita nak go for H. Katalah saya letak H. Dia depends. You boleh letak H kat mana-mana. It's up to you, okay? And then kita ada CN. Saya nak letak CN dekat bawah. And then you have CH3 here. Okay, saya nak letak CH3 here. Then we have this bialkyl group here, right? Okay, so combine lah. CH3. Okay, alright. So this is your original. So it's actually the same molecule. It's just that bila kita target the chiral, this is how it looks like. Nampak tak? Sama je dia punya chain dia. Sama. See? Sama, rantai panjang dia sama. Cuma representation is different. Right. You draw the mirror image. Now you want to draw the enantiomers, the mirror image of this. Okay, so this is how you should be drawing it. Sama, you ada solid line. Okay, you ada solid line. Okay, kan saya kata dia mesti side by side. CH3 should be side by side. Solid line. You should have the wedge. Okay, this is the wedge and this is the dashes. Okay, all right. So down here we have CN, so we have H there. This is CH3 kan, so dia kena side by side. Okay, and then kat sini, here, CH double bond CH3. Siap. Okay. Doesn't matter you nak buat wedge ni CH3 ke, you nak buat this one H ke here, doesn't matter because we are going to refer to your original structure. Okay, it should be the mirror image of your original structure. So because different student may have different representation. So that's why kita tak ada, you must place the hydrogen on top. Bukan macam tu. Okay, right. Okay, so that is all guys. So we have like 30 minutes for 5.3, okay, hydrocarbons, alkanes. But before that, do you have question related to isomerism just now? Ada soalan ke?
No, madam.
Okay. Clear, very clear. This is very important, okay?
Madam, very clear.
Okay, clear, very good. How about others?
Very clear, madam.
Okay.
Clear, madam. Clear, madam.
Alright. Okay, kalau clear, okay, this is based on your response. Let's just proceed to 5.3. Okay, hydrocarbons, the focus is on alkanes. Okay, so for alkanes alone, these are the learning objectives that you should be covering for alkanes. Okay, and then later on we will cover the alkenes and other functional group as well. Okay, I would highly suggest you ataupun advise you to every time we have completed one functional group, Okay, you prepare your, what do we call that, mind map. Prepare a mind map. Okay, did you notice that our slides, your lecture notes, we have 200 plus of slides. Okay, 200 plus of slides. Banyak tu. Okay, so what you can do is that you, after each functional group, okay, you try to go through it again and then compile it and then make a mind map and then compile everything in this one paper. Okay, so you can just simply refer to this piece of paper for you to get all the information in, all the information related to reaction, related to naming ke whatsoever. Okay, sometimes student may prefer dua paper ke nak asing ke, doesn't matter, tapi you reduce from 200 plus into 1 to 2 piece of paper. Okay, tapi you kena go back and extract out the important information, especially the one that has apa nama tu, reaction, because different functional group have their own reaction. So itu nak kena hafal all the reagents, all the conditions and whatnot. So that one need to be memorized. So one of the way to help you memorize is to prepare the mind map. Okay, you have the tajuk dia, organic chemistry, and then you have alkenes, alkyl halide, carbonyl, alcohol. So what are the naming styles, and then the reaction, and then next alkene, naming style, reaction. Okay, then yalah, you buatlah fancy, as interesting as possible. Okay, to attract you to refer to use your mind map as your reference. Okay, it is really helpful because different student ada cara nak buat mind map dia sendiri. Dia buat color lah. Ada student dia prefer to use this point form. Ada students prefer to use different ways lah to prepare the mind map. Okay, but it is really helpful because you refer to only one piece of paper ataupun 2 piece of paper macam tu. Okay, alright. Itu suggestion saya lah. Kalau tak nak buat, it's up to you. Tapi kalau saya rasa saya tak wajibkan untuk nak prepare the mind map. Tapi kalau you buat, rasanya memang sangat-sangat membantu if you take this organic chemistry seriously. Okay, major classes of hydrocarbon. So hydrocarbon in general, it consists of carbon and hydrogen. So it can be divided into saturated and unsaturated. Saturated means all the bonds are single bonds, whereas unsaturated means the molecule consists of multiple bond. It may have a single bond, double bond, or triple bond in the molecule. Okay, all right. So for saturated hydrocarbon, okay, we only have alkenes in it. Because alkenes, all the bonds are single bond. Okay, whereas unsaturated, we have alkenes, alkynes, and arenes. Okay, so alkenes, that means the molecule has double bond, at least one double bond. Alkynes, at least the molecule has one triple bonds, whereas arene is benzene rings. Maksudnya it's a cyclic, but it has double bond in it. Okay, we are not going to cover this in our lecture. Okay, so we have 2 types, aliphatic and aromatic. Aliphatic means chain, maksudnya dia rantai panjang lah. Aromatic on the other hand, okay, it's cyclic form. It is in cyclic form. Okay, all right. Okay, so general information on alkenes. Okay, so it has single carbon bond. So all of them are single bond. And then even the carbon attached to the hydrogen also uses single bond. Okay, all right. So all carbon atoms are tetrahedral. All bonds angle approximately 109.5 because they're tetrahedral in shape. Okay, so the hybridization, the type of hybridization for each carbon in alkenes are sp3. Cycloalkanes are special class of alkane in the form of ring. So this is cyclic form. Okay, so in cyclic form we also have alkanes. So it is known as cycloalkanes. Okay, for example, we have methane. So this is not in cyclic form. Ini chain yang biasa. And then we have ethane. Cyclopentane is cycloalkanes. Maksudnya dia dalam cyclic form. Okay, nampak tak dia hujung bertemu hujung. Dia jadi macam cincin. Dia jadi ring dia situ. So that is what we call cyclic form. Okay, tapi still semuanya nampak tak single bond. Okay, all the bonds are single bonds. Okay, nak classify the degree of carbon and hydrogen atoms in alkanes. Penatnya bercakap. Okay, tak larat nak bercakap dah. Dia banyak cakap sikit untuk organic chemistry ni banyak content dia kat situ. Okay, degree of carbon and hydrogen atom in alkanes. So each carbon can be classified into primary. Okay, whether it is primary, secondary, tertiary or quaternary carbon. So how do we identify whether it's primary, secondary, tertiary or quaternary? Okay, alright, so let's look at primary carbon. Kalau you faham primary carbon, that means you would understand for secondary, tertiary and quaternary. Okay, so primary carbon is when, okay, refer to this carbon, is when the carbon is only attached to only one carbon. Okay, so the R is an alkyl group. Alkyl group is also carbon lah, carbon group kan. So the carbon, okay, this is our targeted carbon kan. We want to determine the degree of this carbon. So kita check, okay, how many carbon is attached to this targeted carbon? We only have one carbon saja that come from this alkyl group. The rest are all hydrogen. Therefore, it's a primary carbon. Okay. Alright, take for example this molecule. So this is ethane. You have to identify for all the degree of carbon in the molecule. So we have two carbons. So each two carbon, every carbon should have its degree. Okay, dia punya degree of carbon. Okay, so kita target for this carbon first. Dia is it what type of carbon ataupun the degree of this carbon? Okay, so kita kena check. So this carbon is only attached to this one carbon. So therefore it is primary. Dia attach pada satu carbon saja kan? So dia primary lah. Same goes to this one. How about this one? So this carbon is only attached to this one carbon. So it's also primary. Okay, alright. Secondary carbon on the other hand, okay, this targeted carbon is attached to two alkyl group ataupun two group of carbon. Attach kepada dua group of carbon kan. So dia adalah secondary lah. Secondary. Because dia attach kepada two group of carbon. Okay. Secondary. So this is secondary carbon. Okay. Look at the example. Okay. You have to determine for each of the carbon, the degree of carbon in the molecule. So this carbon here is only attached to this one carbon. The rest are all hydrogen. So this one is primary. Same goes to this one. Okay, this carbon here is only attached to this carbon, the green carbon here. The rest are all hydrogen. That I'm talking about the I'm talking about the one that is directly attached to the carbon. Directly attached to the carbon. Bukan yang jauh-jauh tu yang directly attached to the carbon. Okay, yang betul-betul buat bond dengan dia. So ada satu je carbon yang betul-betul directly attached to it. So this is primary. Okay, how about the green carbon? Okay, so this green carbon is attached to two other carbon. So this is secondary carbon, guys. Okay, alright. And tertiary. Tertiary, this carbon, this targeted carbon is attached to three different carbon and also one hydrogen only. Therefore, it is tertiary. Okay, alright. So ni semuanya primary. You check, betul di primary. How about this one? Okay, this carbon is attached to directly attached to three different carbon. So this is tertiary. Okay, And then we have quaternary. For quaternary, that means the targeted carbon is attached to 4 different carbon. That means there's no hydrogen attached to the carbon. Okay, like for example, this blue carbon here. So this is considered as quaternary. Okay. Alright, not to forget hydrogen, guys. Hydrogen also have its degree. Okay, so like carbon, okay, hydrogen is even simpler. Hydrogen depends on the carbon, hydrogen depends on the degree of the carbon that it is attached to. If the hydrogen is attached to primary carbon, therefore that hydrogen is primary hydrogen. Okay, like what we have here, primary hydrogen is a hydrogen atom attached to a primary carbon. Secondary hydrogen is attached to secondary carbon. Tertiary hydrogen is hydrogen attached to tertiary carbon. Simple lagi, simple. Okay, so first thing first is you have to identify, okay, the degree of the carbon first. You have to identify the degree of the carbon first, then only you can go for hydrogen, because hydrogen depends on carbon. Okay. Okay, classify the degree of carbon and hydrogen atoms in the following alkanes. Okay, you nak kena classify for all of the carbon in the molecule kan. Okay, so as you can see, they are all in condensed form. Okay, C, we have skeletal and also condensed. I would highly advise you, because you just learn just now kan. Kalau unless you are already a pro, you dah pro, you tengok je dah tahu. Okay, you can go ahead terus directly determine the degree of carbon. If you feel that you are not good enough ataupun you baru belajar, baru nak get the hang of it, okay, let's take it slow. Okay, I would highly advise you to expand this. Expand bagi nampak the bonds. Okay, bila you dah nampak the bonds, sebab ni you kena be careful. You nak kena tahu dia ni, dia attach dengan siapa. Because dia condense kan, when it is condensed form, dia ada bracket dekat situ. It can be quite tricky there. Okay, so I would highly advise you to expand it first. Taklah everything should be expanded. You just mixture lah. You nampak the bond. Okay, so let's draw this in expanded mixed version lah. C, okay, so this C, this one is attached to, okay, buat tangan dia ada 4 lah dulu kan. Okay, it's attached to hydrogen obviously here. So we have 1 hydrogen. And then it's also attached to 2 CH3 dekat situ. Ada dua kali CH3. Maksudnya CH3 dan ada CH3. Betul tak? And then how about this bond? This bond is attached to this carbon. Okay, this bond is attached to this second carbon. And then we have H2, then we have CH3 kan. Ni tak adalah expanded version sangat, tapi dia mix lah. Tapi at least kita nampak bond, what do you call that? The main bond, bond utama kat situ. So barulah kita boleh nampak. Okay, alright. So now we can determine. So this carbon here is only attached to this one. So this is primary carbon. Okay, how about this one? Okay, this carbon is attached to 2 carbons, see? Directly attached to 2 carbons. So this is secondary. How about this one? It is attached to this 1, 2, 3. So this is tertiary. Okay, you have to determine for all the carbon, okay? So how about this one? Dia hanya attach kepada 1 carbon saja kan. The rest are all hydrogen. So this is primary. And how about this one? Kalau you nak kembang, nak lagi nampak, buatlah lagi bagus. That's even better, okay? So this is only attached to this carbon. So this is also primary. Okay? So lebih nampak like macam C kan. Kembangkan ni, you assign dulu, okay, C. And then we have H. Dia ada, mesti make sure dia ada 4 hands, 4 bonds. Okay, cuma 4 bonds tu, sebab we are talking about alkane, so mesti all single bond. So barulah boleh nampak kan. Nampak tak? So this is primary. This carbon is also primary. This carbon on the other hand is tertiary, right? How about this one? Jangan lupa carbon-carbon yang lain ni. Okay, alright. So this carbon is attached to this and this carbon. So this is secondary. Same goes to this one. Secondary, 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 secondary. How about this one? 1, 2, 3. So this is tertiary. Okay, alright. So you have B for you to work it out. So try dulu buat sendiri. Okay, alright. Okay, itu buat kat rumah lah. Okay, saya nak masuk nomenclature of alkenes. Buat kat rumah. That will be your homework lah. Okay, for B. Yes.
Nak tanya untuk degree of carbon and hydrogen kan, untuk one alkane tu kita akan ambil the highest degree ke?
Sorry,
So,
tak dengar.
by one.
Clear lah, Akmal ke?
Tak.
Tak
Dengar
okay, dia macam zzz.
Hello?
Ya.
Hello?
Ya.
Madam, kalau untuk yang degree of carbon dengan hydrogen tu, kita akan ambil yang highest degree kalau dalam satu alkane. Ke each one of the carbon kita akan specify?
Each one of the carbon you kena classify.
Oh, kita bukan tentukan yang highest degree lah untuk
Bukan.
alkane.
Bukan. You kena determine for each one of the carbon. So even though it's in the same molecule, they may have different degree of carbon. Okay, so kita kena determine setiap satu carbon dalam molekul tu sebab dia mungkin berbeza dia punya degree of carbon dia tu. Right? Dia mungkin ada tertiary, dia mungkin ada primary, dia mungkin ada secondary. Ataupun dia mungkin dia boleh mix of all the degrees lah. Okay? Alright. Penatnya. Nomenclature of alkenes. So nomenclature of alkenes. Nomenclature is a fancy word that we use to name. Okay, nomenclature is naming actually. Naming of alkene. So nomenclature is the, like in organic chemistry, to name the compound we would use the word ataupun the term nomenclature. Okay, so jangan takutlah nomenclature ni apa kan? Nomenclature ni naming. Okay, so we have a format ataupun we have a rules that we have to follow. Okay, this was set by IUPAC. Okay, so we have to have a body to set this set of rules that everybody have to obey, to comply with. Okay, imagine kalau different orang, different naming style. So how do we, nak highlightkan compound yang sama tapi namanya berbeza. Okay, so it will be difficult there. So it will be an issue there. So we have to have a body that come up with a set of rules so that everybody will agree that this is the name of the compound that we are talking about. Contohnya. Okay, so IUPAC set these rules in order to name the organic molecule. Okay, all right. So first step. So these are the steps. You have to find the longest continuous carbon chain. That will be the parent carbon lah. And step 2. Okay, basically it's the same as what you have learned before. It's just that you have to few things that you have to consider. Okay, of course the molecule can be quite complicated. Okay, it can be longer, it can be lot of branches, lot of substituents. So there are a lot of things that you have to consider. Okay, tapi dia punya rule of thumb is basically more or less the same lah. Okay, find the longest, must be the longest and continuous carbon chain. You kena try and error dekat situ. Okay, kalau start daripada atas bawah ke bawah going down, okay, we have 7 carbon. Okay, and then kalau straight macam ni, kita dapat 6 carbon. So kita nak go for mana? Okay, kita kena the longest and continuous. Okay, alright. Then step number 2, you have to assign prefix that indicates the number of carbon atom in the molecule and suffix into the parent carbon. Let's say we have identified just now we have 6 carbon. So the name should be hexane. So the suffix will be in hexane. So the prefix will be hex. Okay, contoh. Okay, step number 3. Assign number on the parent carbon. And then you are going to assign number because you nak come up with the naming kan. You nak identify substituent is located in at carbon number berapa. Right? Okay, so you have to assign number for okay, at carbon number 3 we have methyl group, that substituent. So you kena assign number. Okay, beginning with the end of the chain nearest to the substituents. Okay, of course kita akan ada 2 ends. Kita ada few ends lah yang kita boleh consider. So kita nak start daripada kanan ke kiri ke, atas ke bawah ke, macam mana? Kita nak start. Kita akan based on the one that is nearest to the substituents. I mean, dia akan pakai the lowest number rule guys tu. Okay, bila kita compare nanti you kena try and error dekat situ and then you will compare. If I start from the top to bottom, I will get the substituent at carbon number 6 and 7. If I start from bottom to the top, I will get the substituent at carbon number 3 and carbon number 4. Okay, so which one should I choose? You would choose the one that has lowest number for the substituents. Okay, alright. Step number 4, name and number the substituent group attached to the parent carbon as alkyl group. You can identify the alkyl group that are attached to the molecule. Okay, so we have methyl. When it becomes substituents, it will end with YL. Methyl, propyl, ethyl, what else? Pentyl, and so on. Okay, so you can identify, okay, this propyl group is located at carbon number berapa? Carbon number 3. Okay, so it is propyl just now. Okay, and then finally write the name as a single word. So of course you have to consider in terms of comma, hyphen. Okay, so those kind of thing. Okay, let's go through one by one. Find the longest continuous carbon chain. Okay, find the longest continuous carbon chain. Like I said, you have to try and error. Okay, so you can going from left to right, going down. You dapat berapa carbon? You got 7 carbon. Okay, another option you may consider for this one, tapi you only got 6 carbon. Another option, continuous and longest. Okay, you boleh consider for this one. However, it is also only consists of 6 carbon. Okay, so kita nak pilih yang mana? Dia same molecule so we are going to choose for this one because dia kata longest continuous. So ni kita tak consider. Okay? Right. Then what else? Okay, if 2 different chain or equal length are present, choose the one with larger number of branch point as the parent. Okay, so again these two are the same molecule. Cuma consideration yang kita berbeza. Okay? Alright, so going here, kalau kita start from the top going down and then to the right here, you akan dapat 7, still 7 carbon as the parent. This one pun you akan dapat 7 juga as the parent, continuous and longest. You dapat 7 carbon. Pula. Okay, tapi kalau you go for this one, you kena kira substituent. How many substituent that we have? You only have 3 substituents, guys. Kalau you go for this one, this 7 carbon, 1, 2, 3, 4. You ada 4 substituents. So which one should you choose? You should choose the one that has more substituents ataupun more branch. 4 substituents. So we're not going to consider for this first molecule. First method lah. First method nak assign the substituents. Even though there's 7 carbon, this is also 7 carbon. But this one has lack of substituents. Okay? Right. Assign prefix that indicate the number of carbon atom in the molecule and suffix in to the parent carbon. So once you have decided just now, you have decided, okay, this is longer than continuous. So how many carbon do we have in it? So we have 5 carbon. So this is the longest. Assume kita dah set dah tadi. The longest. So we have 5 carbon. So apa nama kalau 5? This is the prefix that we use, pent. Tapi since we are talking about alkanes, so it should end with "-ane". So this will be pentane. So pentane is the parent carbon. Parent. Okay. Alright. Same goes to this one. You have identified the longest one will be the 8 carbon. Okay. Alright. So it will be oct as the prefix and ends with ane. So it should be octane. Okay. Ayo, 3 minit lagi. Penat ni. Step number 3. Assign number on the parent carbon beginning with the end of the chain nearest at the substituent. Okay, nak assign numbers guys. Nak assign numbers. Okay, you dah decided for the parent just now. Ada 7 carbon. Nak assign pun you have to try and error juga. Okay, nak start daripada atas ke bawah ke, nak start daripada bawah ke atas. Kena try and error. Kalau you start from the top to bottom, you akan dapat branch ataupun the substitute at carbon number 3 and number 4. Okay, but if you start from the bottom going up, you akan dapat kat carbon number 4 and number 5. Ha, see? So nak pilih mana? The lowest number as possible. Lowest number rules. See? Dan apa ni? Okay. Okay, if there is branching and equal distance away from both end of parent chain, begin numbering at the end nearer the second branch point. Pula macam tu. Okay, so dia ada 9 kan? So going up dengan going down. Okay. Ni still pakai lowest number rule. Okay, lowest number rule. Okay. Alright, so you kena assign. Okay, you ada branch. Ada 3 branch. This one pun ada 3 branch. 1, 2, 3. Okay, alright. So nak consider apa lagi next? Okay, kita kena consider dia punya lowest number rule. Okay, kalau ni kita akan dapat 3, 4 dengan 7. 3, 4, 7. As a number for the branching ataupun the substituent. For this one? 3, 6, 7. 3, 6, 7. So, you nak pilih yang mana? Kan dah kata lowest number rule. Okay. So, you kena consider yang ni lah, nombor 4 ni. Sama lah, lowest number rule. So, this has lower number than this. 3, 6, 7. So, that's why this one is not, will not be considered. Kita akan pakai yang style ini. Okay, the lowest number rule. Okay, name and number the substituent group attached to the parent carbon as alkyl group. Okay, so like I said just now, so if we have assigned the parent, so that will be the parent, so the rest will become the substituents. So bila become substituents, it will end with YL, 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 propyl, butyl, pentyl, hexyl, and carry on lah. Okay, so kita akan assign dekat situ. So, dia akan ganti dengan ANE jadi patutnya methane. So, since it become substituent, it will end with YL and become methyl, ethyl, propyl, and butyl. Okay, depending on the number of carbon present in the group. Okay, right, next. What else? Okay, if there are 2 substituents at the same carbon, give both the same number. For example, so we have at carbon number 4, we have this methyl group and this propyl group. So both of them will have the same numbering. 4 for methyl, 4 for ethyl. See? 4 methyl, 4 ethyl. Okay? If 2 or more substituents are present, cite them in alphabetical order. So as you can see, we have more than 2 substituent present. We have ethyl dengan methyl. Sudah. Siapa nak kena namakan dulu ni? Kita akan based on alphabetical order. So ethyl will be named first. Kita ikut alphabetical order, bukan ikut numbering. Numbering ni kita nak assign the lowest number possible. Itu saja. Tapi when we want to name the compound, kita akan based on alphabetical order. Even though dia dekat number 4 yang methyl group ni dekat number 3, but we are still going to name them the ethyl first. So it should be 4 ethyl. Sepatutnya macam ni. 4 ethyl and then kita ada methyl group kat number 4 kan. And 3 kan. And kat carbon number 3 sebab dia group yang sama. So you akan 4, 3. Macam tu. Tapi dia ada 2 kan. 2 methyl group. So you kena guna prefix di dekat situ. Okay, sebab ada 2 number dekat sini, so don't forget to use die. Kalau ada 3 number, that means you have to use try. That means the word die here means there are 2 group of methyl in the molecule. Okay, so dimethyl. Hexane. Ta-da! Okay? Okay, and then write the name as a single word. You're going to use the hyphen, the dash. You have to separate the different prefixes and use comma to separate numbers. Okay, alright. Follow alphabetical order. Follow the alphabetical order. Okay, and then assign number. So, ni maksudnya dekat carbon number 3, dalam hexane, dekat carbon number 3 ada ethyl group. And dekat carbon number 2, dalam hexane ada 6 carbon tu, ada methyl group. Itu cara you baca. So bila you draw, you must get the same name lah. Okay, janganlah bila draw nama dia lain. Itu maksudnya salah you punya structure ataupun naming you. Okay, so these are the ni lah. Kalau you want to separate between alphabet dengan numbering, you are going to use ni. Number dengan alphabet, you use hyphen or dash. Okay, if you have number and number like 4 and then you have 7, so you are going to use comma. Okay, again, number and alphabet, you need to use dash. Okay, alright, so you can go through this on your own. These are the example. Maybe you padam this number kan. You padam nama ni, you padamkan and then you try to name the molecule. You try to rename the molecule and then you check sama tak you dapat tu dengan yang kita bagi dekat sini. That can also be your practice. Okay. Alright, so let's stop here. Okay, so kalau ada contoh dekat belakang, kalau ada checkpoint, you can try to do it on your own first. Okay, we will discuss later. Okay, any questions so far, guys, before we end our session? Tu dia. Okay, tak ada good question. Okay, right, maybe you can try it on your own first. Buat dulu tutorial tu, boleh try naming the alkanes. Itu je lah. Okay, so that's about it for today. So thank you everyone for your kind attention. Okay, so we'll see you again. So there will be no class, no lecture for tomorrow because obviously it's public holiday. Okay, Nuzul Quran. So selamat menyambut Nuzul Quran, guys. Banyakkan baca Quran. So we will replace our 1 hour lecture on another day lah, which I will announce later. Okay, alright. Itu saja. See you. Bye bye. Assalamualaikum.
Thank you, madam.